All right, good morning. So today we're going to be taking a look at how to solve quadratic equations, specifically using the quadratic formula. Hopefully you have seen the quadratic formula before, but if you haven't, it's very straightforward. This is the formula right here. We have three variables, A, B, and C, and A is used twice, and so is B. All right, and so I'll let you know what each of those variables actually refer to, but what we want to make sure is that we always have the opposite of whatever our B term is. So it doesn't mean that this always has to be negative, because B could be negative. So if we had like B was -2, for example, we would have -2, which would make all of this a +2. And then we do have plus or minus because we have a square root, right? And so we're going to do b squared minus 4 times a times c. This is all one term, so you want to multiply all this out and then subtract it from b squared. And the entire numerator is divided by 2a. So let's jump into an example and see how the formula works out. So we have three terms that we're looking for, a, b, and c. All right, so we need to figure out what each of those terms, what they each equal. Okay, so a is always the coefficient of your x squared term. So it's nice in this example that everything is given to us in order. Sometimes it might be given to us out of order. So it's important that we recognize that a is the coefficient of x squared. So in this case, that's a +3. All right, b is always the coefficient of your x, not x squared. So in this case, we're looking at this term right here. So the coefficient of x is +16, so b is 16. And c is always your constant, your regular number that has no variable, which is this one right here, which is a +5. So now what we're going to do is we're going to go ahead and plug into the formula. Remember that we're solving for x, so this formula gives us an answer for x, right? If we plug in, we're going to get the value for x. So let's go ahead and plug in for the variables that we have. So the first thing that we need is the negative of b. So b is 16, and negative, or you can almost think of it as the opposite. The opposite would be -16. And then we have plus or minus. I'm going to open up a big square root. Then I have b squared. So b is +16, so I have 16 squared minus 4 times a, which is 3, times c, which is 5. All right, and all of that goes over 2 times a. And a is, once again, 3. Okay, so we can go ahead and start simplifying this. I would recommend simplifying this by hand and not using your calculator to plug in the whole thing. You can use it to plug in some things, and I'll show you, but you want to, the radical especially, you want to simplify on your own. So I'm going to just bring over the -16 plus minus, and I just want to see what's inside that radical. So I'm going to go ahead, actually let me do it over here. Oops, that was for my last class, sorry about that. And I'm going to go ahead and plug in just what's in the radical. All right, so I'm not even going to put a square root, I just want the inside value. So I'm going to do 16 squared minus, and just write it out exactly how you see it, 4 parentheses 3 parentheses 5, right? So that's the entire radicand, and I get 196. All right, and all of that goes over 2 times 3, which is 6. All right, well, let's keep simplifying. Let's check and see if we can reduce this anymore. We're either going to have to simplify it, or maybe it works out like perfectly. So I'm going to do the square root of 196 and first check and see if it works out perfectly. In this case, it does. So I have plus or minus 14/6. If this didn't work out perfectly, you would have to just simplify. You guys already know how to simplify radicals, all right? Okay, so what this means, this is actually two different equations. We have -16 plus 14 all over 6, but we also have -16 minus 14 all over 6, all right? So we need to figure out what those two values are. We don't want to leave it like this because we actually do have like terms, so we can simplify. The only time you leave it in plus minus form is if you have unlike terms, like one integer and one radical or something like that. So let's take a look. Negative 16 plus 14 is negative 2 all over 6, and that equals negative 1/3. So that's one of my answers. Negative 16 minus 14, I get negative 30. All of that divided by 6. Well, negative 30 divided by 6 is negative 5. So what I'm going to do is, as my final answer, you can write this in a couple of different ways. I like to do x sub 1, so one of my answers is negative 1/3. X sub 2 is negative 5. Those would be my two final answers. You could also just list them. So you could just say x equals negative 1/3, comma, negative 5. Just make sure you don't make that like a coordinate, because these are not coordinates. Those are the values for x. And that is how we solve using the quadratic formula. So we're going to do another example that's a little bit more complex. All right, so let's get right into that one. So we have example 2. All right, and we are going to solve for 1/4 m squared. So already we see some fractions, but we can deal with fractions. They don't have to be scary. Okay, so the first thing that I want to do is I want to get rid of my fractions. So hopefully you guys remember how to clear fractions. All right. If I find the common denominator for all of these, there's a 1/4, there's a 1/1, there's a 1/2. The common denominator would be 4. So what I'm going to do is I'm going to multiply everything, meaning both sides, by 4. And that's going to give me an equivalent equation, but with no fractions. So if I just start distributing, we'll get the new equation. So 4 times 1/4 m squared, that simplifies to 1m squared, so I just have m squared. 4 times negative 4m is negative, 4 times negative m is negative 4m. 4 times 1/2 is 2, and 0 times 4 is 0. All right, that looks much, much better. So let's go ahead and figure out what we're going to plug into our quadratic formula. So we still need a, b, and c. So a is a coefficient of the squared term. In this case, that's 1. B is negative 4. And c is positive 2. All right, let's go ahead and plug into the equation. So we need negative b, right? I'm using this equation. So we need negative b, or the opposite of b. Okay, so b is negative 4, the opposite, or the negative, so negative 4 is positive 4. Then I have plus or minus a big square root. All right, so I have b squared, so that's negative 4 squared, minus 4 times a, which is 1, and c, which is 2, all over 2 times a. So let's go ahead and start simplifying. I'm going to bring over that 4 plus minus. All right, and let's go ahead and see what we get for that radicand. You could just do that in your head, honestly. If you're going to use a calculator and you have a negative that you're squaring, please make sure that you put it in parentheses, or else that's going to really trip you up. All right, so we get 8, and then 2 times 1 is 2. All right, well, we can definitely simplify this radical. The square root of 8, if we think about 8, that's a 4 times 2. So I can take the square root of 4 and I get 2, and I'm left with a 2 inside the radical. Alright, so these two are not like terms, so we can't create two separate equations like we did in the previous example, so we will have to leave the plus minus, but we actually can simplify this in one more way. If you take a look at what we're dividing by, we are dividing by 2. We have to check only the coefficients, only the constant terms. So we have to check if both of these terms are divisible by 2. And it has to be both. It can't just be one. And they are. So what we're going to do is we're going to divide both of them by 2. Okay? And we're going to simplify. So this is going to end up being 2 plus, I don't need to write 1, right? 2 divided by 2 is 1, but I don't need to write that. And I don't need to write over 1 because this also gets divided by 2. So this right here is my final simplified answer.